Hello, and welcome to this Getting Started guide for GEMS Offshore Pile Foundation Analysis software developed by Geotechnical Engineering Modeling Software GEMS. Piles are used to provide foundation support to wide-ranging structures such as buildings, bridges, wharves, jetties, towers, and offshore structures like oil platforms and offshore wind turbines. The GEMS Offshore Pile Foundation Analysis software is a specialized software for analyzing pile foundations for offshore structures. Our other offering, GEMS Comprehensive Pile Foundation Analysis software, caters to pile for land-based and waterfront structures. The software includes modules for pile capacity estimation, axial load analysis, and lateral load analysis. Various common procedures for analysis used in practice are included in the package. Subscribe to this YouTube channel to stay appraised of our upcoming videos, products, and tutorials. The software is available for a 30-day trial download from our website for Windows and Macs. One can also try the online cloud version for 30 days from our website using a browser. If you haven't installed a copy yet or signed up for a cloud account, this may be a good time to do so. Visit our website https://www.gemsoftware.org. This is a two-part video. In the first part, we will have an overview of the application, start a new project, and estimate the capacity of an offshore pile. In the second part video, we will apply axial and lateral loads to the pile and perform axial and lateral load analysis of the pile. Let me launch the application. The look and feel is the same on Windows, Mac, and cloud platform. The usual menu bar, File for file operations and preferences, Edit, Compute, and Help, which includes detailed documentation. The application window is divided into 5 panes. Project Properties pane is used to define the overview of the project, type of the analysis being performed, number of load cases, and the unit system. Input Parameters pane. This is where you will define all the detailed input parameters. The next 3 panes, Pile Capacity Estimation, Axially Loaded Pile Analysis, and Laterally Loaded Pile Analysis, give the detailed results of the analysis in tabular and graphical forms. These will get populated once we run our analysis. In this video, we will estimate the pile capacity of an offshore pile 20 meters in length, 1 meter in diameter. The pile is a hollow steel pile with 3 different sections, each having a different thickness as shown in the table. The soil consists of 3 layers: soft clay 10 meters thick, stiff clay 5 meters thick, and a sand layer 10 meters thick. We will use some typical soil properties shown here for each layer for the sake of this demo. These would normally come from the soil investigation report. Let's enter the data. Click on the Project Properties tile and enter some data. Project title, Offshore Pile Getting Started, example 1. Project description, Getting started with analyzing an offshore pile using GEMS Offshore Pile Foundation software. I will copy and paste some additional information regarding this project. Project number, Offshore Pile Example 1, something easy for you to track. Project executor, GEMS. Analysis module. We have 3 different analysis modules available. pile capacity estimation, lateral analysis, and axially loaded analysis. We will first determine the pile capacity and then determine the loading scenarios. We will just keep pile capacity estimation selected to begin with. You can find more details in our product overview video. Number of load cases. We will visit this when we perform axial and lateral load analysis. Units. We will use the SI units. For our engineers in US, you can use the common American units. We are done with project properties. We will look at input parameters to define the details. This pane is divided into 4 tabs. Pile dimensions defines the type of the pile and the dimensions of the pile. Pile properties defines some of the pile properties like material, pile head condition, pile and plug weight, and pile group properties. Soil properties defines the site condition, layers of soil, and the property of each layer. This pane is also used for viewing and defining PY curves under static and cyclic loading conditions, TZ and QZ curves. Load cases define the loads applied on the pile for axial and lateral load analysis. Let's start with pile dimensions. Pile length 20 meter and a pile diameter of 1 meter. Enter the pile thickness in the pile thickness table. Our pile has 3 segments, 5 centimeters thick up to a depth of 3 meters, 3.75 centimeters thick up to a depth of 18 meters, and 5 centimeters thick up to a depth of 20 meters. The mandatory fields are highlighted with a red star. There is help available at your fingertips. Click on the question mark adjacent to any field. Click here for details will open the relevant help pages with additional information. The pile diagram shows a pictorial representation of the pile and will update as you make changes. Let's move on to Pile Properties tab. Select the pile material from the drop-down menu. We will use the default ASTM 36 steel in this case. The elastic modulus and unit weight of the material is shown below. The effective pile weight automatically updates based on the pile dimensions and the material selected. Once we update the soil properties, the plug weight will also be updated. One can prescribe the pile head boundary conditions. We will visit this in a later video when we perform lateral analysis of the pile. There is also a provision to evaluate pile group effect by using P multiplier, Y multiplier, and Z multiplier approach. We will cover this in a later video. We will next enter the soil properties. Click on the soil properties tab. There are 5 sub-tabs on the right hand side here. Soil layer tab to enter the details of the soil layers. PY static and PY cyclic to view generated values or to define custom values for the PY curves. TZ to view generated values or to define custom values for the TZ curves. QZ to view generated values or to define custom values for the QZ curves. By default, the PY, TZ, and QZ curves are automatically generated based on the soil properties. These will be covered in more depth in a separate video. The soil layer sub-tab is what we will focus on today. It is divided into 3 panes and we will enter the data about the site condition, subsoil layers, and properties of the corresponding soil layer. We have 3 layers of soil. Let's add the required rows in the soil layer table. We will next specify the soil type in each layer and thickness of each layer. Soft clay, 10 meters thick. Stiff clay, 5 meters thick. And a sand layer, 10 meters thick. The starting depth of each layer is automatically updated. One can insert new rows, delete rows in the middle by right-clicking on this table. The soil properties of the selected layer is shown in the adjacent soil layer properties pane. Let's review and update each of them. The application populates some typical values based on the soil type. For the first layer, we have soil type soft clay, starting depth 0 meters, and layer thickness 5 meters. Enter the submerged unit weight gamma 6 kilonewton per meter cube. TZ code determines the method for pile capacity estimation and axial analysis. PY code determines the method for lateral analysis. We will leave them as API 2011. You can find more details on this in our product overview documents and help pages. Based on the selections, the required soil parameters for analysis are marked with a red asterisk. This being the top layer, let's change the cohesion at the top to 0 and cohesion at the bottom as 20 kilonewton per meter square.
The rest of the parameters, J constant, epsilon 50, R factor are not used for pile capacity estimation, and we will leave them as default values.
We will move to the next layer and select the second layer in the soil layer table. We have stiff clay, starting depth 10 meters, layer thickness as 5 meters. Submerged unit weight of soil gamma as 8 kilonewton per meter square. We will keep the TZ code used for pile capacity estimation as API 2011. We will set the cohesion at the top as 125 kilonewton per meter square and cohesion at the bottom as 150 kilonewton per meter square.
The rest of the parameters, J constant, epsilon 50, R factor are not used for pile capacity estimation, and we will leave them as default values.
Finally, we select the third layer, sand layer, in the soil layer table. We have starting depth 15 meters, layer thickness as 10 meters. Set the submerged unit weight of soil gamma as 13.2 kilonewton per meter cube. We will evaluate pile capacity using API 2011 by setting TZ and QZ code as API 2011. We will now set the required parameters for sand soil. Relative density medium, shaft friction beta 0.27, limiting shaft friction F lim 81.3 kilonewton per meter square, limiting end bearing Q lim 5000 kilonewton per meter square, and bearing capacity factor NQ as 20. Finally, let's set the local scar as 2 meters in the site conditions pane. It's best to do this after defining all the soil layers, as there are some restrictions on scour and the application may give validation errors if one tries to do this earlier. One must use values from the soil investigation report for all parameters. We will come to the load cases tab in another video. This is where one would enter the loads for lateral and axial loading analysis. If you go to the Pile Dimensions tab, we see that the pile diagram has been updated with the soil layers. We can also see that the plug weight has been updated based on the inputs in the Pile Properties tab. Let us see if our inputs are valid and there are no errors in them. From menu bar, click on Compute, Validate. We see that our inputs are valid. We have entered all the required information for getting our pile capacity. Now let's click Compute. We get the message that pile capacity estimation is complete and the tables are updated. The results are available in the pile capacity estimation pane. Pile capacity table. The pile capacity table tabulates the estimated pile capacity at various depths and soil layers. The table breaks down the total pile capacity into its contributing factors, namely shaft friction and base capacity. Unit resistance table contains the unit shaft friction and unit base resistance available to the pile at various depths and soil layers. Analysis graph plots the contents of the pile capacity table and unit resistance table. At the pile base of 20 meters, we can see the total pile capacity to be 4,375 kilonewton. Shaft friction contributes 1,767 kilonewton and the base resistance contributes 2,607 kilonewtons. One can also perform just the pile capacity calculation by clicking on the Compute Pile Capacity at the top of this pane. The results can be copied by right-clicking on the table, select all, copy. The graphs can be copied by right-clicking on the graph and selecting copy and pasted outside in your desired application. One can export the analysis results to Excel and Word if required. File, export to Excel. File, export to Word. As you can see, the application is intuitive, versatile, and very easy to use. To summarize, in this video, we went over the GEMS Offshore Pile Foundation application, defined dimensions and properties of a pile, defined site and soil properties, determined the pile capacity of the pile at various depths. If you have queries, please email us at support@gemsoftware.org. Also, do like this video if you found it informative. Subscribe to this YouTube channel to stay appraised of our upcoming videos and products, and share this video with your colleagues. Thank you for watching.